That's a leaf.
And as the demand needed. So our first unit on the Nevada side was N2 was the first one to go online, and that was in October of 1936. Turbines have been upgraded. They were put in originally. The output was about 112 megawatts. They were a high head turbine. They put in a medium head turbine.
We're kind of shaking that tires again. You ready? Keep your fingers shut.
We're going to pull up here next to a little alcove, and I'd like everybody to get off the bus and head on your right into this little alcove. And there's a large diagram here that I can show you, very similar to the one I handed out, but this one's easier to see. I'll explain a little bit about the system, and then what we're going to do is get on this boat and take a little ride on the boat. So anyway, here you can see the hydraulic gradient of the system. This starts on the Colorado River. Somebody asked me earlier what's the elevation. Here it says it's 450. So where we're going to go at our main spot, 450 feet by sea level. You can see that the water's flowing up and down. This is Copper Basin right here. That's where we're at. And then you can see this long stretch. It's over 60 miles. And the whole idea behind that was to control the rate of curing of the concrete. If you could control the curing, it dramatically cuts down on cracking, and you end up with a better product. They also used chilled water. They had a chiller plant up on the hill, and they would run chilled water through pipes embedded in the concrete. Wow. Okay, after we get all tied up and secured here, we're going to get off the boat. Okay, if I could have your attention quick, I'll just point out a few things and then you can do your pictures and all that. If you look on each abutment on both sides, you'll notice that the dams keep back into the rock a little bit. There's still a little bit of leakage. You'll see the plants down here along the edges of the dam, so there is some leakage here. Most of that is through the rock itself. You can see there's obviously faulting on both sides of the abutment over there on the left. These faults are, of course, were studied before the dam was put in here and found to be inactive, meaning probably no movement for the last 10,000 years. That's one of the interesting projects that's coming up. I guess it was put on hold for a while, but they need to replace that valve down there, and they need to do that while there's water in the reservoir. So they're going to have to bulkhead off that outlet somehow on the upstream side and then remove the valve, put the new one in, and it'll be an interesting project. One of the things that you'll see here are the reflectors on the wall here. That's newer, a newer way of monitoring the health of the dam. What that is those are laser reflectors. We can set laser equipment up at different points. You see these white posts? And there's actually one right behind this gentleman here. They can attach laser survey equipment.
That doesn't have treatment. In the center of the basin that they treat it peripherally. You know what?
Yeah. It's a little steep there.
is that function? We take that.
Okay, the question is, do we have volunteer water testers that come out and test our water? And my answer is that we have the money to do it in-house, and actually we have a whole water quality group that's what they do. And one of the things they do out here is samples are taken and clear up into the Lake Havasu, like the headwaters of Lake Havasu, and we fly those samples into town. I would encourage, if you ever have a chance to go on a tour of our water quality lab in Laverne, that you do that. It's really pretty interesting. Okay, so this is the outlet structure. It's the beginning of the Whipple Mountain tunnels, and there are gates. You can see those stems in the center of each one of those sections, and at the end of those stems there's a gate that moves up and down. And so it's all underwater. You can't see it right now, but that's how the water leaves the reservoir and heads towards town. Start building or rebuilding the nest and get ready for a new batch of offspring. And normally you would see those eagles here in the evening. A lot of times during the day they're out hunting, but you never know. You can see them anywhere. But it's really cool to come up here when the little ones are in their nests, because you can see their little heads, bobbing around in there.
Boats which have been used in infested waters and subsequently lakes, and that's how the water got.
And it comes down through this canyon. And again, we needed a measuring spot to report our return flows. But in this case, I thought these guys were pretty smart. They made that weir structure just a little taller than you probably would have needed to, but it sure made a nice swimming hole. So this is known as the old swimming hole down here. And we have a picnic area down here that's sort of developed. We have horseshoe pits and nice covers and barbecue pits, and a lot of retirement parties and all kinds of different events take place down there. Yeah, we actually have a reservation system on our intranet, our internal internet system, where you can go on the reservation system and reserve the old swimming hole for events. That tallest mountain up there is called Black Metal Mountain. You can see it now to your left. And that is a Metropolitan-owned communications site. We have a few of those across the desert. We own some sites up near Hoover and by Laughlin, Nevada, Christmas Tree Peak. We have those spots across the desert that were secured many years ago, way back when we were using analog communication systems. Representative from the pump plant, and they're going to conduct the tour. They usually have headsets for us. I don't know if we'll use them.
Design. I'll show you one later on. We go outside there on the motor room floor. But getting back to copper a little bit, we adjust the water levels. We have agreements with Edison and the Department of Energy to load shedding agreements. We've all seen situations where power outages or shortages. So we have, if there's not enough power in Southern California. And what happens is the lake elevation is down. It'll drop about 4 feet or so. It depends on, it's not a square box, of course, so it varies. But we can do that for up to 4 hours and still maintain full flow in the aqueduct.
They go back was always fun, always thrilling, but no more.
Oh, how sweet.
We could conquer the fatal dryness of the great American desert.
I didn't really appreciate what this place was all about at 10 o'clock at night. I woke up in the morning and I opened the blinds and all I saw was barren desert. And I thought I'd landed on the moon.
We pick our water up and lift it 441 feet. And then it's gravity flow all the way to DVL and Lake Matthews, and got a long tour, long ways to go through all the tunnels.
It went all the way gravity by itself.
From here. Once you leave our head, it flows all the way over there. And,
I remember going through Manning when we used to come out here. You better slow down or you'll get a ticket.
yeah, I'm not part of the freeway there.
You ready?
You guys are making my day today.
Well, let's go ahead and we'll go out here to the motor room floor.
Do you want to say your name and when you worked here?
I'm Bill Ehlers. I worked there when I was 19 years old, back in 1935.
Job.
My job, I weighed out all the material for the concrete with the scales, automatic scales.
And you were 19 years old at the time.
They were the scales were operated by I forget now. They automatically after they got the certain. We usually went up to 1,200 pounds on each material.
I was gonna get a can of cryo and cover that up. When we dewater these units,